Okay, this is the second part of this structural bay demonstration using simple lines with thicknesses at the moment. We've completed the first bay, and what I'm going to do is copy one side of that 3 meters apart, 3 meters away. So I'm in the world coordinate system at the moment. I'm going to go back to a 2D wireframe and then copy, and using the crossing window, so I pick up the full length of the beams but not pick up these columns as well. Press enter because I don't want to copy anything else. Base point can be anywhere. Ortho's on, so I pick my base point, drag to the side, and then just tell it I want it 3000 away. Enter. Enter to stop. Now what I'm going to do is keep it 3 meters at this side but have it 1.5 meters at this side. So we're going to stretch the whole junction here back the way by 1500. So use the stretch command. That is just the letter S. So S return. You have to use a crossing window, that's the green one again, and you only get one selection. You can't do 2 green windows, it's just got to be the one, so you've got to get everything in one go. So just grabbing this whole junction, enter. Base point can be anywhere, ortho's on, so you can see what's happening. The column's okay, but the shorter beam isn't getting any smaller, and the other beam isn't getting skewed, it's just moving along. Okay, so we'll set it to 1500. Okay, and then get a bit closer and see what we can do. Okay, when we shortened this, when we extruded this, I gave it its thickness before, we used the change command. Now if we do that this time, the problem will be it started off at this side and then got longer in this direction. So just watch what happens if we use that -CH again. Pick the 3 bits. Now there's got a message here saying some of the objects I picked weren't parallel to the UCS. So you can see that my X and Y are on the ground at the moment. X and Y need to be in the same orientation as the beam section. So that was the right coordinate system. So it's -CH. Grab the bits we want to change. They're highlighting this time. Okay, press enter. We did properties, thickness, and this is the thickness I'm wanting. So I'll put my object snaps on. From here to here, enter. It's on the other side. Now we could just pick that up and move it, okay, but what I'm going to do is change to a different type of component. So we'll undo that, and we're going to go to 3D faces instead. So on my layers list, I'm going to create a new layer and call it shape 3D face. I'll make it cyan coloured so we can see it in comparison to the others, and I'll make it current and close. Okay, so we're going to do this in quite a different way. Now a 3D face is kind of the simplest of 3D forms, so let's just draw a couple over here. So remember we're in the kind of the vertical plane at the moment, so 3F, and you can do a 3-sided one, so that's pick 1, pick 2, pick 3, enter, enter to stop. If I shade that, you see we've got a surface. Okay, you can do 4-sided ones. So 3D face again, 1, 2, 3, 4. It automatically closes. Okay, now notice the way I picked, it was kind of anti-clockwise. I can go clockwise as well, but I can't do a kind of butterfly shape. If I just demonstrate that, so 3F, 1, 2, 3, 4. it kind of folds over on itself, so it's kind of not usable in that state. Okay, so it's either got to be clockwise or anti-clockwise. So anti-clockwise or clockwise. So that's how we create them. So we need to give ourselves a little bit of 2D work to draw with. So I'm just going to draw over the end of this section. And if I move those now, okay, from here to here, we've got the kind of shapes we need to trace over it. Okay, 3D faces are independent of the UCS. They're not tied to it. Lines and polylines, however, do remember the coordinate system that they were generated in. So it's 3F, enter. Let's do the top flange first. So it's 1, 2, 3, 4. Now the web. 1, 2, 3, 4. And we could copy the top flange down or just draw another one. 1, 2, 3, 4. Enter to stop. Okay, we can get rid of the beam that's not behaving. Okay, and if we shade that, we should have, it's the same type of appearance, but it's a more editable object. So what I'll do, I'm just going to copy that out the way. Okay, let's just bring it over here. Okay, so this is far more fluid. It can be pulled and pushed and dragged any which way we want. Okay, and let's just copy it again. Okay, and what I've got to remember though is if I stretch it in this direction, notice the flanges are getting thinner. The web is the same, the web's okay, it's just longer, but the flanges are getting thinner. If I put it back on top, if we go perpendicular across the beam, then that flange is thinner than it was before. So you have to be careful if you want to try and keep realism, or accuracy anyway. This one's a wee bit trickier. Let's go back to 2D wireframe. So we need some material to help us draw it. So I'm going to change to using the make current, go to the setting out layer, and I'm going to copy that upwards. Copy that line from there to there. Going back to the world coordinate system, and I'm just going to draw a line partially along here. Okay, I'm going to use the nearest object snap, so that's shift and right mouse. I can look for nearest, and I'm just going to pick a point here. Enter to stop. Okay, this is one of the kind of trickiest commands in AutoCAD. So reference rotation. So it's rotate. We want to rotate the beam and that bit of new line. Enter. We'll rotate around this point here, so the middle of the column web. Okay, but I get to this point and then I don't know what the angle is. I don't know how much to rotate by. I'm not just going to guess. Okay, so I use a reference rotation from base point to the end of the set out line. Now you can see I'm in control of it, and I'm looking for the end of that long set out line down to there. So that's kept the beam in its true state, but unfortunately it doesn't quite meet on this side and it oversails on this side. So what we'll do, we could stretch these, but it's probably easier just to set up a bit of 2D stuff and then draw some fresh shapes. So copy, I'm going to copy this from here to here and here. Okay, and I think I'll take it to here as well. Okay, let's just get rid of this, and we can see then that this line needs to extend and this one needs to trim. So a fresh line, okay, just across there, trim, or fillet. So that's touching now and that's touching. We've got to do the same at the other end. Okay, I think visually we've lost something there. Oh, it's over here. Right, the lines are a long way away. They're too small bits. So let's just draw across there. And I think probably easiest to use fillet, extend for this. Pick my barrier, enter, and make those whiz right the way along. Okay, let's get rid of this bottom flange. Okay, I think we can get rid of the web as well. So we've got all the 2D setting out we need. Okay, so let's do the top flange, 3F. So 1. Oh, let's make the blue current now. Let's go back to that. 3F, enter, pick, pick, right the way down to here, pick, pick. Okay, now copy that down by the web height. And then we can draw the web in. So 3F again, midpoint, endpoint or midpoint, endpoint, midpoint. So we've got a much more accurate but still simple shape. Okay, and it doesn't matter where we cut this, it's still the same section size. Okay, now what I'll do is just make this current and switch off these two just now, because there's a few extra lines we could get rid of here. We're a bit overloaded with lines. I think that's all of them. That's good. We'll bring back on those. And what we'll do now is move to the to the final modeling type, which is solid models. We can use the setup that we've got here, okay, or I think we'll copy this one actually. Save switching layers off again. So we'll copy the framework there from endpoint here, and I'll plop it on the end point there, the midpoint. Okay, we need a new layer. Okay, so this is shape solid. So I'm going to use solids instead. So these are nice and easy to create, but not so easy to edit, and even worse than the thicknesses, to be honest. But the speed in creation kind of outweighs the editing issue. Right, back to 2D wireframe. So the shapes we need are kind of already here. When you did this exercise last year, you polylined them at the end so that you could fill them with hatch pattern. Okay, so they're already polylined, ready to go. So we just need to drop this using the middle of that yellow line. I'm just going to drop it into position. So I'm going to copy, pick the column shape, enter, use the middle of that line, and we can drop 4 of these on. So I've got endpoint, endpoint, end, and end. Okay, and this is where these commands start to come in now, using the solids. Okay, let's make the shape solid our current layer, and what will happen is when you extrude these, they go onto the current layer. So extrude, all 4 of these, enter, and we'll pick the end of that line. They're showing dash there. I think I've accidentally kept the line type there. They want to be continuous. Okay, very simple. And the advantage of this is that we've got all the detail and we've got a lid as well, so they look, you know, very realistic, look very solid, hence the name. Okay, the short beam is probably the easier of the next two, so we'll do that one next. So we need to copy this into position like we did the yellow items. So Shift Control C, I'm going to pick the top middle of the flange as my base point, and then pick the shape and enter. Okay, I need to be in the coordinate system that is the side of that flange, so that would be the left or right, and as it stands that's kind of facing me, that's the right side. Okay, Shift Control V to paste it in. I'm looking for the middle of the flange. Okay, because it's been pasted in as it is a block, we need to explode it first. X, enter, click, enter. Don't explode it again or you'll stop it from being a polyline, and if you do that and try to extrude, you get this appearance. Okay, that kind of indicates that it's not a polyline anymore. Okay, when it's a clean closed polyline you don't see any of that gridding. So extrude. Let's start that again. Right. Seems to be kind of highlighting automatically. I'm not sure what's going on there. So extrude, pick, enter, and I could pick here, 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 or even down here, as all it's going to read is the Z difference. Okay, so it's not the actual distance on the diagonal, it's just the difference in the Z coordinates. So if I pick here, that beam will be exactly the right length. So as you can see, nice and easy. We need to go back to the world coordinate system to pick up this beam now. Same manner, same way. Shift Control C. Use the top middle of the flange, pick the shape, enter. Okay, it's a different UCS for the placement, so we want to go to the front UCS. We want to be kind of facing the web of those columns. So front. We have to be a bit more careful with placement here. We're not placing at the top of the setting outline, it's going on the middle of the web. So Shift Control V, the midpoint of the web, explode it just once, then extrude it. Okay, so pulling it, and we're going to end point, midpoint, or end point. That looks good. You know, it's immediately, you know, very accurate looking. You know, but for analysis, for FEA, you know, it's way over the top, and the system probably wouldn't even want it. It's really wanting this kind of arrangement. Okay, we've got a bit of copying to do, so let's go back to 2D wireframe and copy this beam first. Let's go from the setting out point to the setting out point and copy this one. Similar way, setting out point to setting out point. Could have copied it. Oh, I've moved that. It's off. Moved both of them. Oh, idiot. Should have picked the wrong icon. Sorry. Move and copy right next to each other. So copy. Let's just do it numerically then. So ortho on 3000. Copy this one 6000. Because they're nice round numbers, that's easy enough. Okay, so we'll do the same kind of thing here. Let's see what happens when we try to edit this. So we'll get the copy this time, not move. Grab all this, enter, orthos on, base point, set your direction, 3000. Okay, try the stretch again. Okay, we get exactly the same situation. Okay, so we'll go back 1500, but to sort this out is quite a different affair. Now watch what happens when I click this. Some marks appear around the shape. I've got quite a few marks at the end here, so I could change the profile. I could edit the shape of the beam. Okay, and we could edit the length of the beam. Okay, so we could make it longer or shorter. But problem is, it's only operating from this end. It's the same situation as the thickness. It would be great if that arrow was at the other end, but it's not. So I could solve this in a couple of ways. Do we rotate the beam so we kind of flip it so that the end ends up at the extendable end ends up at this side? That's a possibility. But generally, the kind of quicker way is to just chop the end off. So what I do is use a rectangle. Okay, I'll go back to the world coordinate system actually and do a rectangle. Okay, and this is big enough to capture the bit of the beam that I want to get rid of. Okay, and now I extrude it downwards deeper than the height of the beam. So extrude. Okay, so we're well down below that. And then we can use these commands here, these Boolean commands. There's union, subtract, and intersection. And these are really useful, nice and quick. So what we want to do is subtract part of this beam. So subtract, you click the object you want to subtract from, then press enter, and then the shape that you're going to cut it with. Enter. Okay, so we've got our beam the correct size. Notice though that the extension arrow is now gone, and so are the points for editing the shape. When you do that Boolean operation, it basically kind of dumbs down the solid quite a bit. So always in CAD there's kind of other ways of doing the same thing, but we'll kind of go with that. Right, this is even more tricky. Okay, so we need to rotate it and then make the beam longer so we can chop some of it off. So what I'm going to do is pick up this set out line and copy it from its end point, and we'll put it on the middle, back onto this end point. Okay, so we've got a reference line. Let's copy this diagonal setup line from endpoint to the same place. So this is the angle that we need to rotate by. Okay, so we're in the world coordinate system, so we're okay. So we want rotate. We're rotating the beam and the vertical setup line. Enter. Base point. We don't know the angle, so we need to do a reference rotation from base point to the end of that set out line, which is here. Okay, if I switch ortho off, you'll see that I'm in control of the beam now. Okay, and this is where we go to the end of this diagonal set out line. And that's it. Absolutely accurate. Okay, now though, we want to make this longer. Okay, so we could extend this end. Now, I'm not sure if this is going to go, it's staying in the same direction. That's okay. So that one's an easy stretch. Okay, the other end isn't though. We can't get it to go this way. So what we do here is we need to set ourselves up in this coordinate system. So that would be the origin, X direction, Y direction. Okay, and this is where this little command comes in. UCS 3 point, origin, X direction, and shift and right mouse, nearest, and I can pick up any position on the edge of the flange there. Okay, if we do plan now, this is the only beam that will be kind of vertical. So plan, enter twice. And you notice that both of these are both vertical while everything else appears to be rotated. Let's go back to this view. If I put ortho on and then copy, pick this, enter, and when I move it, we're moving in the same direction that the beam's facing. Now we could have just used a bit more extension on this end and then move it, or I'll show you the union command. If we copy it, doesn't have to be very far. Okay, they're both kind of overlapping each other now, but if you union it, they become one. So union this, and that will disappear, and it becomes fused together into one. It's like melted into one. Okay, now what we want to do though is our subtraction. So this is a bit cruder. Let's do it from the top. Let's view it from the top, and we want to create a shape that's big enough to chop that end off. So it's a polyline, not a spline. Okay, use a polyline. Okay, I'm going to go from here to here and then switch ortho off, and I just need to go around the end of the object and close the shape. Okay, do the same at the other end. This seems really kind of crude, and it is. So pretty much doing the same thing at this end, big enough to capture it all and close. Now these could be on the ground, and they probably are. Ah, not this time. They were on the ground before. We're okay, they're both at the top of the columns. So let's extrude them. We can do them both at the same time. We want them to go downwards, deeper than the beam, and then subtract from the beam, enter, and we subtract both of these at the same time. And that's us tidied up the connection. Now the sharp-eyed amongst you will notice a bit of a problem here. We've got an overlap there. In reality, the end would probably just be notched. They'd just take a little chunk out of there. That bit's not doing a heck of a lot structurally. It's more the web that's doing the work. That little bit of flange there is not. It's so close to the column that its integrity is fine. So losing a little bit there wouldn't be a big deal. And that's what the steel fabricators do. They kind of look for these issues and tidy things up. So when it comes to site, there's no cutting that notch on site. It's already being considered. Okay, the final touch to this is to add some bracing. Okay, so let's create a bracing layer. What I'll do, I'll show you the bracing first so you get the idea, but I'll just create the layer while I'm here. So we'll just call this bracing, and let's make it red and make it current. Okay, and let's just show you the bracing first. Okay, so that's the red items here. Okay, and you can see that the brace is kind of going to the very bottom of the beam and it's aiming to the setting out point at the top. Okay, it might be taken sometimes to just underneath where the beam hits the column. Here you probably have a bracket and take it there, so that kind of keeps the kind of continuity, the direction going kind of to the top. So let's draw that onto this one. I'll just close that. Okay, our brace layer is ready to go. Now what we want to be, at the moment we're in a UCS for the top of the beam. We really need to be in a UCS for this wall, this angled wall. So let's go to 2D wireframe so we can see what we're doing. And I think I'll turn this off temporarily. Okay, we've got a couple of extra lines there that we don't need now. So it's UCS 3 point again, because we don't know what the angle is. Now I could adjust this. The laborious way would be UCS enter Z enter 90. Okay, so X is running in this direction now, and then I'd have to rotate it around X to get Y pointing up this line. So it would be UCS enter X enter 90. So that's facing the right way, but it's not necessarily in that plane. Okay, so what you could do is UCS enter origin, so you type in the letter O, enter, and you choose a new origin point. Okay, now that's quite a lot of work. 3 point is much quicker, so let's go back to world, go straight to 3 point. Okay, origin, X direction, any of these are okay for the Y direction. That's a bit quicker. Okay, and that's why that kind of, it gets used more than manually controlling it. But it's still, be aware of that. All you need to do is specify which axis you want to rotate around, and if you remember that left hand rule, so the Z is your thumb, X is your middle finger, Y is your index finger. Okay, so let's just draw simple lines, a little cross for our kind of cross brace. Let's go right to the, I think we'll take it as if we're going to the very top of the column. Okay, big cross brace there. Okay, we'll put a tensioning ring in the middle here, so we'll use a circle. Okay, this is very accurate. These lines do hit each other and they intersect, so we'll intersect there, and we'll put a radius of 150. I want this to look solid, so I'm going to give that thickness of 10 millimeters. That's thick, that's strong. So we offset by 10, enter, and take this out the way. Okay, now we need to give it some solidity in this direction. So it's extrude, pick both, enter, and we're going to come this way 30. Okay, now at the moment this is completely solid. Okay, but what we need to do is subtract the smaller circle, the smaller disc in the middle from the outer one. So it's subtract again, pick the outer disc first, enter, and then jiggle around a bit until it gives you the center one. Enter again, and there we go, got our ring. It's a bit far forward because we've gone positive 30 here. We actually need to go half that depth back the way. So it's move, pick our ring, enter, base point can be anywhere, put ortho on, and that way we can slide in this direction. So set the direction, and we're going back 15. And now you can see that the brace lines are going, and they're hitting exactly kind of midway on the object. Okay, let's make this look a bit more realistic. We'll draw another circle, and I'll make it 125 radius. I'll use that to trim off the ends of these. So trim, this is my cutter, enter. Get rid of those. I don't need that. So it's looking much more realistic now. But these are just, hairline width. We need to solidify these, so I use a circle there. So C, enter, and just a little circle, 7.5 millimeter radius. Copy that another 3 times, because when we use the next command, it uses the shape up. So the command is sweep. Not sure if it's sitting there. I think if we go to solids, we'd find the sweep command. There it is. Sweep. Okay, you pick the object you want to use for the profile, enter, and then you pick the line to extrude along. Enter, pick the object, enter, sweep guide. Pick the object, enter, sweep guide. And there we go. And these would have kind of bolts and be threaded, and you can tighten this and it will make that rod, put it into even more tension. Okay, what we'll do now though is try and trim off the tops of these. So we need to see where the beam is. So let's bring the beam back. Okay, we're still in the correct UCS. So let's have a look at this in 2D wireframe. Okay, so what I'll use is a large rectangle. We'll go from this end point, make it pretty big. Okay, I'm going to move it, I'm going to slide it this way slightly, and then extrude it back the way. Okay, it doesn't have to go too far. Depth of the beam a bit more, and then subtract from this and this, enter, pick this, enter. Now when you do that though, notice these two get joined together. Okay, so what I'm going to do, actually that looks a bit strange. I should have actually gone to this setting out point, but it doesn't matter. Okay, when you get this situation, when you've subtracted and it kind of unites things, there's a command here called separate, which allows you to change those. Okay, and what happens now is they're both individual. They're still solids, they haven't been blown apart. Okay, let me just show you what happens if you do accidentally explode a solid. Okay, it's one object at the moment. If you explode it, okay, it still effectively looks solid, but it's made up of what are called regions. So we've got region, region, this is a region. So if I shade that, you'll see they're still surfaces, but they don't all united anymore. And if you explode them again, they change to lines. So they're just lines now, lots of them. Okay, so that's what happens if you actually accidentally explode a solid. And in Rhino, you can actually put the regions back together quite happily. You don't have that benefit in Autocad. So if you remember to go back to the world UCS, you can either go here or type UCS and enter twice. Okay, I'm annoyed with myself that I've gone and set that outline. It looks very strange like that, but we'll not lose any sleep over it. Okay, so that's just a little example on different kind of modeling techniques. Beyond this, we have kind of mesh objects, and these are more kind of softer kind of shapes. You find that people want to use these if they're kind of sculpting, but the mesh objects do come into FEA modeling. And there's also, we have surfaces, NURBS surfaces, and these are even more sophisticated, but extremely clever. AutoCAD kind of plays these a bit of lip service. It's got them in, but it's not very good at editing at all. If you're needing to use NURBS surfaces, that's when a software called Rhino comes into play, and it's been specifically designed to be extremely good at using NURBS surfaces. So things like kind of racing cars, racing helmets, rockets, ships' hulls, where very smooth curved shapes, for aerodynamic performance is important. That's the software people go to first. Okay, you don't tend to use Rhino to generate building models. Definitely parts of buildings, but usually it's for more tricky components than whole buildings. Okay, I hope you found that useful. I enjoyed creating this bit of teaching material, and look forward to seeing what you come up with your bridge designs.